So we'll just slowly get started. Thank you all for joining today's Fair and Biological Practice workshop. So this is a very much an interactive hands-on workshop in addition to the teaching. So we want to teach you how to apply open science FAIR principles in your daily research practice. So just to give you a bit of an introduction, Anna Kreshuk is a EMBL group leader. So her group focuses on machine learning-based methods for developing tools for image analysis. And she's also involved in open source software for bioimage analysis. To talk to us about how can open science help accelerate method development. So without further ado, I'd like to pass the floor to Anna.
Thank you very much, Victoria. Yes, let's try that. Let me try to share my screen though. The usual fun of the Zoom talks, right? I guess you can see it now. Yeah, so I wanted to just say a couple of words about how open science, of course, is important for all of us, but also there are some aspects of it that can become important that maybe you haven't thought of if you're not working sort of directly at the link between the two disciplines, that I just wanted to highlight to you to maybe give you even more motivation to engage in the open science activities. Right, so what is open science? It's kind of a murky thing, right? So I think for most people define it as rather not what is open science, but what we know is not open science, and what we know we don't like about the closeness of the practices that we see, well, less right now, but let's say that we have seen when the whole movement was starting a few years ago. So clearly, something like this, which has now become a real meme, is not what we mean by open science, right? So, you can't charge money for, especially for papers about the inaccessibility of science. But it's not only about open access, because after all, open access things really affect, let's say, citizens who want to engage with science, people from developing countries. But if you're already working at EMBL, you have access to everything you need, right? So it's not affecting you personally that much, even though, of course, all the other considerations are also important. But then there are also these other things which are very annoying, right? Such as, I'm sure you have seen that if you've ever looked at papers that are, more than a year old, right? All this like data is available upon reasonable request, and somehow it's always a reasonable request, right? So they are still going to decide if they want to share data or not. Right? Same goes for code, right? That the scripts are also provided from the corresponding author on reasonable requests. And if you ever had the experience of trying to make this kind of a reasonable request, you will soon see that, especially for code, usually the corresponding author has no clue, right? Because the person who actually wrote the code already graduated, right? And for data, it's also, well, yeah, we had it somewhere, let me see. But in the end, I think there have even been studies like this where people try to go through this to the reasonable request stuff and never heard anything back in the majority of cases. To be fair, it's getting much better. So to make the screenshot to give this talk, I actually looked through the last 3 issues of Nature Methods and have not seen any of the ones where data was only available upon reasonable request. But a few years back, of course, everything is like this, right? So we know that this is not what we want to have. I think the most broad definition of open science, which is, I think was primarily used when the whole movement was started, is yes, that we want to make the publicly funded research results and the data that accompanies these results, because data is, of course, also part of the results, publicly accessible in digital format, right? And so essentially, it starts from sharing your publication and sharing the data that has made you capable of drawing the conclusions in the publications, but then grown to something that is actually much bigger. So if you look at the current definition as defined by the EU through the many projects that are now funded to foster open science, you see there are actually very many components. And the ones that are really, from my point of view, foundational for everyone who is working in science, right, is the open data and open source. Right? Because in the end, open access you can gain, you can buy, you can find. Right? Citizen science is great to have, very important for the society, not important for your day-to-day work, maybe. Scientific social networks is great for the impact, but also, you can work even without this. But without open data and open source, it's really, we are kept to repeating the same things again and again, and this is extremely inefficient and really affects the work that we are doing every day. Right? And that's why this is really what we can start off. And then if you think, okay, suppose that we want to do the open source and open data part. So if you just think about open source, if you put the code on GitHub, I'm sure you guys will look into that more in your whole days dedicated to open source. So I just wanted to kind of throw it out there for you to think about. If you just put your code available on GitHub, or even worse, like people used to do a few years ago, if you just like zip your code and put it up on some institutional file exchange, is that enough? Probably not. And it's already better than nothing, but you would still need to have it documented and especially runnable by others, because the code that just hangs there that you can't rerun, it's not very useful. At least it needs to run on the same data that was used in the publication. And I think in general, for all the open science things, you have to think about reuse or at least reproducibility, right? So using exactly the same components that were done in the publication, can someone else repeat all this? Right? Because publishing, well, if you do this kind of, single time publication that everyone forgets about, sure. But if you actually have the ambition of creating any impact with your stuff, if you want people to engage with it, if you want people to look at your data, at your code, then you have to think about reuse. And the same goes for open data. If you just make your data available through a Dropbox link, that is of course not enough, right? You still have to think about having it properly documented. In this case, well, having all the appropriate metadata. But also I think what is very important is to think about having it future-proof. Because even from my own PhD, I have papers now from say 2012, 2011, where data was made available on the institutional server. It's gone now. I can't recover it. I have no idea. There are people still asking me for it. I can't do anything about it. It's died on some computer 5 years ago. No one has a copy. So I think here it's really important to not just store it in a link somewhere, because these links will die. Your institutional servers will die. Everything like over there will not outlive a few years horizon. So here again, you really have to think about reusing it. Imagine yourself going back to reanalyze this data a year later. And if you want to go bigger, you can see how much the EU actually recommends us to keep in mind, right? So it needs to be discoverable with the tools, with documentation, linked to the other data, with the proper metadata, preferably lying at the open data portals. You will look into that in the last days of Jean Karim. Jean Karim is a big fan of that. He will tell you all possible details. But in general, I think if you want to look at the absolute baseline that you can't go below, you have to share the data with metadata in a way where you can find it again a few months, a few years from that point. So if you have this, if you have the source, if you have the data shared in a consistent way, this is, I would say, already engaging in open science quite nicely, and takes us much further than what the state of the field was a few years ago, and even honestly further than it is now. And then this is like, if we consider that as a minimal baseline, then what I would say is the maximal point that people are striving for now are the so-called FAIR principles. And if you have ever looked into open science, you must have heard about this, because they are really touted at every corner there. So FAIR stands for findable, accessible, interoperable, and reusable. As you can, if you think about this a little bit, you will see that FAIR is actually much bigger than just open, because in the formal definition of open science, things don't have to be findable, right? You just make it open, it's downloadable from the publication, but it's not findable in the sense of someone being able to search for it and just find the data set. Same goes for accessible or interoperable or reusable. So I would say full compliance to the FAIR principles is really more of the, kind of the target, right? Where open science is the road. And the further we get on this road, the better it will be, and the better it will be for the whole scientific community. Right, so so that was kind of the more of a general introduction, and I know you guys will look into that much more, and also have interactive exercises for this in the carpentry style. So EMBL has an open science policy that, and I was in the working group that established it, and it was not even that much of a discussion, because it seems like everyone is extremely supportive of doing more open science at EMBL. So here I wanted to share some of Victoria's slides with you that she has kindly shared with me, so that you would actually know where we stand for this as an institute. And yeah, so here the open science policy concerns articles, data, and software, and emphasizes really progress over strict compliance. And just think about how far can you go, how open can you be, how transparent can you be with your research. And the more you can do, the better, the happier EMBL will be. We have guidelines about this. it has all been in line with what the funders now all require. Right? So if you want to see, for example, for publications, right, we want to have the final versions deposited, we want to have preprints in the beginning, least restrictive licenses, and now there is also a central budget for open access fees, so there is really no excuse to not publish things open access. And if you want to think about the data, I think the important point is that, yes, we want to share all the data behind the study, including the data that did not make it into the final figures that you have put into the paper. For that, there is an utmost important thing is the data management plan that everyone has to think about before they actually start data taking. And the reason why this is important is that this step is actually not recoverable, right? So if you, everything else, right, and you can do the whole work and then say, let's make our paper open access, right? But there is nothing that you now need to go back to and reconsider. Whereas if you have not made the data management plan and have not recorded the metadata that you need, well, it's too late if you're already at the stage of actually writing the paper. So think about that stuff, and like the data management plan is the one thing you have to think about in the beginning of the study. Right? The publication and so on, it's not difficult, and there are also people who can help you, but thinking about how to manage your data, this is the non-trivial part. Right? And then also for software, but these are the kind of things that people usually think about when they start software work. Yeah, so we want to have open source licenses as a default. Of course, sometimes, especially if there are industry collaborators involved, you will not be able to make an open source license, but this is really should be open source first. So I have very strong feelings about this, and everything we develop is very open source. And I personally don't think that science should ever be published based on closed source software. Not everyone is that radical, right? And some people think that, no, that's actually perfectly fine as long as everyone understands what has been happening. But I think it's clear that overall the field is moving to more openness, and for your own software, really consider doing it open source and don't be afraid to publish it. Right? So people are always thinking like, yes, but my code is so bad and this and that, and I should really take a month to make it so much better. In reality, I understand all these concerns, but I can't think of a single case on Twitter when I have seen people criticizing the code of others. Right? When I have seen anyone being any less than completely congratulatory of seeing someone finally releasing the code. Like, I don't even know if anyone ever discusses this in private. Right? So like, oh, these guys released the code and the code is so crappy. Right? It's never like this. It's more like, finally, there is code for this beautiful paper and we can reproduce this, or at least see what they've been doing. So don't be afraid. And people who criticize others for the quality of their code are jerks anyway. You don't have to care about them. Make your code open source. So in the very final part of my talk, I wanted to, so actually give this promised interdisciplinary perspective. And the reason why my research is really dependent on the open science there is that we are in this kind of symbiotic relationship with the people who produce data, because we don't produce any data ourselves. And a few years ago, there was this big calamity from a paper published in New England Journal of Medicine that introduced the term of research parasites. And yeah, this is kind of what we are. And in this, there have been 2 awards established. They're the Symbiont Award for people who release the scientific data in the most beautiful and shared way. Right? And this would be, well, all the people in the biology labs that we are so happy about. Right? And then there are people on the other side, which is people like me. Right? And these are the people who reanalyze the data that has been actually created by others. So in our case, we are not even parasites ourselves. We are like enabling the parasites, because we are creating methods that allow people to analyze the data that has been published. And I think here, for our existence and in general for the growth of science, having someone who shares the data and is extremely important. And at the same time, for our community to grow and to produce reliable work, it's also very important that these kind of open science guidelines are absorbed in our community as well. Right? And here, I want to go back to the topic that we are studying, and what we do microscopy image analysis. And for image analysis, or the whole domain is called computer vision, the really driving force of progress are the open challenges and benchmarks. And in there, I'm showing you just the one example, the so-called ImageNet challenge. This is the most famous one, and you can see just how much it's used and how much it's cited. And ImageNet is, so this kind of images, right? So with images just showing one object, and that's been really instrumental in getting computer vision to where it is now. And the reason why people in computer vision like benchmarks so much is that they have early on, before all the open science movements, allowed people to really compare apples to apples. And so you have a data set, you know how well you're doing, you know how well the other people are doing, because the leaderboards are all public. You don't need to rerun anyone's source code. You don't need to have arguments about, oh, they didn't run it properly, or they didn't readjust the hyperparameters, they didn't do this, we are actually better. The leaderboard is public. You know how well who is doing. So you can really show that you are state of the art. And there is a single clear metric of you being better than everyone else. It's the ticket to publication in the computer vision world. And so the benchmarks are really fundamental in this case. And of course, the ImageNet is like the super big one. It has millions of images and thousands of classes that people have labeled using Amazon Mechanical Turk and other kind of cheap labor. There are also very many others, and driven by the big success of ImageNet, people have also proposed a lot of other benchmarks. Not all have taken off, but many have, and it's still a good way to make impact in the field, is to create a data set that covers an angle that has not been covered yet and draw the others to run their code on them and to try to really solve this problem. So in microscopy, which is, well, yeah, the domain where we are all active, it has not been so easy. And the reason for it is that it's really an interdisciplinary problem, because the people who are trying to create the methods are not the ones who need to create the data. And at the same time, the results being, well, in the computer vision world, publications are not directly usable by the people who have created the data. Right? And so it's hard to get the gold standard, because PhD carrying biologists need to annotate. And at the same time, yeah, you really need to have a very tight collaboration for people to do that. But the results are so good. And in here, you can see an example of the data science bowl that was organized by Ann Carpenter in 2018. Thousands of people have contributed to it. And in the end, that has led to now emergence of the problem that they want to solve. So that's the nuclear segmentation benchmark that is now practically solved. Right? So the methods that we have for it now are really, really good. And the one benchmark I wanted to point out to you, because this has really led to the emergence of the field where I did my postdoc, right, is the so-called ESB 2012 Neural Segmentation Challenge. It's very famous in the connectomics field. And here, this data was provided by Albert Cardona, who is a very, very successful neuroscientist, and still considers the contribution of this data set one of his biggest contributions to science. It's very small. It turned out to be very important. Right? So if you look at the leaderboard improvement, right? So you can see like the human being at almost 1, right? And this is where we have started in 2012. This was one of the first uses of deep learning in microscopy. And yeah, you see how much we have covered since then. This would never be possible without having this open benchmark. And I think so it's got a little bit better in 2022, but I think we have essentially saturated the data set. And we probably cannot do much more on this. And the new benchmarks are all bigger and better, but still this is the one that has really ticked it and made the whole thing go and made the computer vision experts interested in solving the neuron segmentation problem, at the same time making the connectomics people able to benefit from it because it was all done together. Yeah, so in microscopy image analysis, like I said, there is a problem of data, there is a problem of applications of models. So my lab, together with many collaborators and friends, have been trying to get to create a single place where this kind of things can be shared, right? Where the models can be shared, where the data sets can be shared, and they can kind of find each other. So we've been building this Bio-IMAGE.io resource. And I think there's a long way to go, but we recently got some EU funding to really make it all happen. So I hope that we can get further and you'll be able to share your data through it, and we'll be able to share the models that we train on your data through it. Yeah, so to summarize, I think the minimal open science that everyone really has to do if they want to feel like a decent scientist receiving public money is to share all the data and code that happens in their throughout their published research. The maximal open science is the full obeying of the FAIR principles. EMBL has an Office for Scientific Information Management that can help you do much more and actually click and check off all these boxes. And that's all I wanted to talk about today. Thank you very much.
Great, thank you so much, Anna. That was so inspiring to see the direct benefit of open data sharing in the field of neuroscience and image analysis. That was really incredible.